Hello students! So this video here is on exterior angles of triangles. Now in our most recent or in our last previous lesson we discussed the triangle angle sum theorem, which sort of talks about the sum of the three interior angles of a triangle. So in this video, even though that we'll still have those interior angles inside the triangle, this video is really going to be focusing on what's the relationship between the exterior angles of a triangle and what sort of things we can do with that. So again, we're going to go ahead on and get started. We're going to give you a little bit of background information. Again, folks, in that last video, in the most previous video, that lesson that we did with the triangle angle sum theorem, we went back to basics and we went back to discussing, okay, polygon, triangle, the different types of triangles, based on classifying them by the angle measurement, like acute angle, obtuse angle, right angle, all that stuff. And we went into the triangle angle sum theorem. So folks, let's go ahead on and get started with the exterior angles. And let's look at what exterior angles are, and some of the background information that you need to know before we discuss that particular theorem about exterior angles, which lets us know what type of relationships we have with exterior angles of triangles. All right, we're getting started right now. Okay, so folks, we can't really talk about exterior angles of triangles without first discussing what adjacent sides are, and really what adjacent sides are in any polygon. And guys, seeing as to how triangles are a triangle is a type of polygon. Again, we need to discuss what exactly we mean when we say an adjacent side of a polygon, and that's going to help when we get into what exterior angles are. All right, so here we go. Adjacent sides are two sides of a polygon that are side by side and that share a common vertex or corner point of a polygon. Now, folks, don't get this twisted with adjacent angles, which we've been talking about, where we've got two angles like this right here, or where we got two angles like this. We're not, again, folks, a lot of this stuff sounds similar, but we're not talking about adjacent angles, okay? So right now we're not talking about adjacent angles. You hear me? Do you hear me? We're not talking about adjacent angles. There's a difference between adjacent angles, which have a common vertex and a common ray that they share. Okay, so we're not talking about adjacent angles, and I'm about to erase all of that right there. Okay, so let's get that clear. Okay, we're not talking about adjacent angles right here. These are adjacent sides for a polygon. Okay, so adjacent sides are two sides of a polygon that are side by side and share a common vertex. And guys, when we talk about a vertex for a polygon, we're talking about a corner point of a polygon. And you can see in this diagram that I have right here exactly what we mean by a corner point of a polygon. Now, guys, so again, folks, that's what we mean when we talk about adjacent sides of a polygon. So again, the two sides that are side by side like that, two sides of a polygon that are side by side, and they share a common vertex. Now, folks, we've used the word vertex several times in our class. And I'm talking to my students who are enrolled in my classes at our school. You know who you are. You know who you are. All right, so we've used the word vertex several times, but in this context, folks, it's different from where we've used vertex before. We've talked about vertex in several different contexts. When we were talking about quadratic functions, and we had I know that's a little sloppy, and we had those parabola shaped graphs where we had relative maximums like that and relative minimums like this, where the vertex was like either the highest point or the lowest point And I'm just giving you a little bit of context because right now when we're talking about vertex in context of a polygon, we're not talking about this kind of vertex right here, where it was literally like the relative maximum or relative minimum. We're not talking about that kind of vertex, okay? Relative maximum or relative minimum, where it's the highest point compared to all the other points, or it's the lowest point compared to all the other points. We're not talking about that here, okay? So that's not the vertex that we're discussing right here when we're talking about polygons. All right, I'm going to erase all of that. Erase all of that, including this thing here. So that was one particular context that we discussed vertex in, right? And the most recent way that we discussed vertex, the word vertex, was when we were discussing angles, right? And when you have an angle, that vertex is that common end point for the two sides of an angle, right? So we discussed that where the vertex is a common end point for two sides of an angle, and we know that the two sides of an angle are those two rays that share that common endpoint. And so again, we're not talking about this type of vertex. Well, technically it is this type of vertex, but it's in a different context here when we talk about the vertex of a polygon. So again, folks, I don't want you to get confused because a lot of these words sound familiar to what other things we've discussed in this class as well, in previous videos. Alrighty, so these are adjacent sides of a polygon, and we need to know about that before we discuss exterior angles. Alright, so folks, here we go. An exterior angle. And so guys, here, now I know this video is about exterior angles of triangles, but folks, an exterior angle is something that exists for any polygon. So guys, an exterior angle for any polygon, including triangles, is an angle that is formed by one side and the extension of an adjacent side. And guys, so an exterior angle for any polygon is formed by one side and the extension of an adjacent side past their shared common vertex. So just to kind of show you, even though I've got a little diagram right here where you can clearly see, again, you can see a pentagon. With that first little picture that I've got here, you can see a pentagon and you can see two adjacent sides there, right? And you can see their common vertex that they have. And then I've got another picture here where you can see another pentagon, right? And you can see it shows your exterior angles here, where you've got a common, and I'll erase this afterwards. Where you've got one side, yeah, okay, that doesn't look nowhere near the way that I wanted that to look. Hold on 1 second, y'all. Just 1 second. Give me 1 second here. Well, you got one side. Okay, yeah, that ain't really gonna do it neither. Let's try it there. Let's try this here. There we go. Well, we got one side of it. All right. So it's formed by one side and the extension of an adjacent side. So you see here, I'm going here to an adjacent side. So this is an adjacent side. What I'm going right now, and I'm extending out this adjacent side. You see it? Do you see it? Do you see what I'm doing? I'm extending that out. You see that right there? You see how I'm extending out this adjacent side? Awesome. So where we've got this side right here, and this extension right here, you see that? This extension of the adjacent side, and it forms this exterior angle right here. You see that? Awesome. I'm glad you can see. Wonderful. Now, yeah. But anyway, cool. Alright, so again, folks, an exterior angle for any polygon is formed by one side and the extension of an adjacent side past their common shared vertex. And so again, folks, it doesn't just have to be a pentagon like what I've got here. It can be any polygon. It can be a rectangle, which we know is a quadrilateral, four-sided polygon that has four right angles, right? It could be a rectangle. And so if we were looking at one side, at one particular side of a rectangle, and then if we wanted to look at another side, but we wanted to extend that side out past their common vertex. Well, where's their common vertex at? Well, I'm so glad you guys asked. Their common vertex for these 2 points is right here. Their common vertex. So, again, if we were talking about extending, oops, hold on, wait a minute. I ain't trying to do that. I wasn't trying to do that. If we were talking about extending out that adjacent side past their common vertex, right? Then your exterior angle would be this angle right here. Now, folks, we can have more than one exterior angle for a polygon. But again, folks, that's how we get an exterior angle. Okay? All right, well, we've got one side and an extension of an adjacent side. And those two things, they form an exterior angle. All right, so again, we should have a pretty good idea as far as what an exterior angle is. In our previous video, we discussed what interior angles were already. So you shouldn't have any issues with knowing what an interior angle is for a polygon. Yeah, one of those angles that's inside of the polygon, right? Awesome. Lovely. Okay. Alrighty. Alright, folks, I got to erase all of this. Give me one sec. Give me one sec. Okay, so again, folks, any type of polygon, all polygons can have exterior angles. But again, folks, in this particular lesson, we're talking about the exterior angles for a triangle. So let's look at particularly what an exterior angle and what those look like for triangles. Okay, so guys, let's look at what exterior angles of triangles actually looks like. What do the exterior angles of triangles look like? And also, guys, let's look at what they don't look like. All right? So you can see here in this diagram to the left right here. Yeah, you see that. You see that all the way to the left right here. All right. So you can see in that diagram right here. Let me get that there for you. All right. You see which one. I got it selected for you. Okay. Acting like you don't know which one I'm talking about. All right. So that one that was right there. All right. And so in this one you can see they're showing one exterior angle in this diagram where they've got this side. Okay. And that's one of the sides of the triangle, and they've got an extension of one of its adjacent sides, and you can see the exterior angle that gets formed there for this triangle. Okay. Now, again, folks, as I've mentioned here, that again, polygons can have they can show you more than just one adjacent. Sorry, they can show you more than just one exterior angle. So again, folks, there can be much more than just one exterior angle for any polygon. And so in this second triangle that you see right here, yeah, that one where I got that little thing right there, you see it right there, the one in the middle right here. In that one, they're showing all three exterior angles for a triangle, for this triangle, or they're showing three exterior angles. Guys, and so you can see those ones that are highlighted in green there. And so, folks, those three exterior angles that you see highlighted in green there are exterior angles for this triangle. And you can see the difference between that and these three interior angles. Angle A, angle B, angle C, which are three interior angles. You can see the difference between those three interior angles and the exterior angles that are shown in this diagram. And then, folks, in this last diagram over here, to all the way to the right, so this one right here, and folks, they've I guess, yeah. The website that this picture came from, And I guess for this particular picture, they've got their name up there. I give them total credit for it. I didn't make this picture. This picture came from mathbits.com. Apparently, they got their little franchise mark on it. Their name is exclusively theirs. They had it on the internet. Well, I don't know all about all that, but anyway, they got their little name up there. So, but anyway, ain't none of these pictures up here I didn't make them, but anyway, they got their name on that one. Just want to give him a little shout out. Whoop whoop. Okay, great, awesome. All right, so in this picture here, you can see that they have not only just 3 exterior angles, but in this one they've got 6 exterior angles that they're showing for this one triangle. Guys, angle 1 is an exterior angle. Angle 2 is an exterior angle. Angle 3 is an exterior angle. Angle 4 is an exterior angle. Angle 5 is an exterior angle. And angle 6 is an exterior angle. And guys, in this triangle that you're seeing here, that I'm talking about right now, to the right side, only those 6 angles that I just listed, angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, only those angles are exterior angles. Guys, these angles that I have highlighted here in yellow that say no. Those 3 angles that say no and that are highlighted in yellow are not exterior angles for this triangle. Okay, folks? Again, so I'm trying to show you what exterior angles look like and what exterior angles don't look like. Okay, so let's just look at this angle here real quick, so you see what's going on. So you see what's going on right there. Okay, you see that they've got that interior. Oops, give me a sec. They've got that interior angle for this triangle. So they've got this interior angle right here. And I'm just going to write that interior angle. So they've got that interior angle. Yeah, that ain't how you spell angle, but it'll be alright for today. Y'all know how to spell angle, and so do I. Alright, they got this interior angle right here, okay. And then, folks, they've got a vertical angle to that interior angle. So, folks, now again, folks, we've talked about vertical angles. We've been talking about them for a while now, in our last few little previous videos. Alright, they've got this vertical angle right there. For that exterior angle. We talked about how vertical angles are formed when you got 2 lines intersecting, and how those 2 vertical angles are non-adjacent, and how they are facing opposite directions. So again, folks, it's not like vertical angles should be something that's new to you, something for my students enrolled in my classes at our school. So again, so folks, you've got an interior angle and this angle. This angle these 3 angles that I've got highlighted in yellow, even though they are on the outside of the triangle, those 3 angles are not exterior angles for your triangle. Because again, according to the definition of an exterior angle, the definition for an exterior angle is where it has to be formed by one side of the triangle. So one side of the triangle, which you see right there, I'm showing you one side of the triangle, and it has to be formed also by an extension of an adjacent side of a triangle. So guys, by the definition of an exterior angle, folks, this angle that they're showing you right here is not exterior. Not exterior at all. Folks, the exterior angle that's formed by the side and the extension of an adjacent side, just to show you real quick, that's formed by that side. Oops, yeah, I know that's sloppy. Give me a sec here. Let me make that a little bit smaller. That's formed by this side. Maybe that looks a little bit better. Yeah, we'll see. By that side and this extension of wow, yeah. And this extension of this adjacent side, yeah, that really don't look like an arrow. Hold on. Let's try that again. A little bit better. looks more like an arrow. All right. So again, you can see that according to this side and the extension of its adjacent side, the exterior angle would be give me a sec, would be this one here. This one would be an exterior angle. Okay? So I'm trying to show you folks that again that the angles that they have the angles that I have highlighted in yellow there are not exterior angles, because they don't go according to the definition that we talked about for exterior angles. So again, this angle right here is just a vertical angle for one of the interior angles. All right, I'm gonna zoom out a little bit right there. So again, that angle right there is just a vertical angle. Vertical angle for one of the interior angles. Vertical angle of an interior angle. Or vertical angle with one of the interior angles. It forms a pair of vertical angles with one of the interior angles. How about that? With an interior angle. All right, so folks, again, I'm trying to make sure that you get what exterior angles for triangles look like and what they don't look like, okay? And it should be pretty clear based on what I'm telling you here. All right, so folks, from here we're going to actually talk about the theorem that goes along with exterior angles of triangles, and we're going to talk about what types of relationships we have when we're looking at the exterior angles of triangles. But again, folks, y'all know me. I don't really like the way this right here look. I'm about to erase this, okay? So again, I'm trying to show you what those exterior angles of a triangle look like and what they don't look like. And I think I've given you enough detail to see what they do look like and what they don't look like, okay? Based on the definition of what an exterior angle is for a polygon. Alrighty, so that's that. We're going to move on and we're going to look at what types of relationships those exterior angles have. What types of relationships exterior angles of triangles have, and the theorems that go along with that, okay? Next up. Okay, so now folks, now that we know what an exterior angle looks like in triangles and what an exterior angle doesn't look like for a triangle, now we can discuss the exterior angle theorem. So guys, this theorem, this exterior angle theorem, now of course folks, we know that exterior angles can exist in any type of polygon, but this theorem here is exclusive to triangles. Okay, this one is talking about triangles, only with triangles. Okay, so this thing here doesn't necessarily apply to all polygons. Okay, so this theorem here is exclusive, and I'm not saying that it can't apply to other polygons, but it is exclusively talking about triangles here. Okay, all right. So just so you know, okay, I am going to erase that right there because I don't like the way that look. I really don't. Okay. Y'all know how I is about that. Y'all know how I am about that. All right. So, so the exterior angle theorem, and again for triangles, this is for triangles. So what it says, or what the exterior angle theorem states, is that the exterior angle of a triangle is equal to the sum of, and when we say the sum of course, guys, we're talking about the result of adding those things together. So the sum of, or adding, is equal to adding together the two opposite interior angles. Now, some of you might be looking at the word opposite and might be thinking, Mr. Saki, what you talking about when you say opposite interior angles? Well, you know what, y'all? I am so glad that y'all asked. What am I talking about when I say the word opposite? When I say the word opposite, what I'm trying to say, another word that you can replace opposite with is remote. So now, guys, when we think of the word remote, like for instance, like somebody could be stranded on a remote island, right? So when you think of the word remote, we mean a far away place. a far away place, right? Something that's far from something else, like like a remote island or something like that. Or think about when you're using a TV. Now this is for some folks. For some folks, when you're using a TV and you feel like, okay, I'm gonna be honest. Sometimes we use our remote when we are like literally like 1 feet away from the TV, 1 foot away from the TV, when we're not all that far away from the remote. But guys, a remote control, the remote for a TV or something like a TV was created to be able to control that device from a far distance. So you wouldn't have to actually get close to it and push a button on the TV, right? Like that's normally what we use a remote for on the TV when we're far from the TV, and we can just push the button on the remote instead of having to get close to the TV and pushing the button actually located on the TV, right? So again, the word remote is another word that you can use instead of opposite, and that word remote means far from. Or non-adjacent, okay? So when we're talking about the two opposite interior angles for that exterior angle, we're talking about the two interior angles that are far from that exterior angle, or the two interior angles that are not adjacent to that exterior angle. So folks, when we look at oops, give me a sec. I wanted to do that as sort of like a I can't really get that to look horizontal. Closer. I'm good a little bit. Okay, that's better. All right. So when we're looking at an exterior angle, like the one that's in the diagram, like the one that's shown in the diagram right there, and I'm going to erase what I got, because I don't really like the way that looked. When we look at that exterior angle and the interior angle that's right beside it. Now I'm talking about when we look at this, and I'm talking about from that picture, from that diagram that I've got there. When we look at that interior angle that is right beside it, that's adjacent to it, right? That's that adjacent interior angle. That's right there beside it. So we're not talking about that adjacent interior angle that's literally right beside that exterior angle. So again, folks, we're not talking about that one. We're not talking about the one that's really really close to it. Okay, we ain't about to be lazy and use our remote when we real close to TV. Okay, I take that back. Some of us are. All right, no judgments here. No judgment. It's okay. All right. So again, folks, So again, we're not talking about the angle that is right beside the angle that's right beside that that exterior angle. So we're not talking about that adjacent interior angle, but we're talking about the one that is the two that are not adjacent to it. Okay, that adjacent interior angle that's the closest to your exterior angle. We're not talking about that one, okay? The one that's the closest to the exterior angle, that's literally adjacent to the exterior angle. We're not talking about that one. We're talking about the other two interior angles. Y'all get what I'm saying, right? Because I think I'm doing a thorough job of trying to explain this. What I mean when I say the two opposite interior angles or the two remote interior angles. We're not talking about the adjacent interior angle, which is the closest one to the exterior angle, but we're talking about the other two interior angles. Y'all get what I'm saying? I hope so, cause I'm spending a few minutes just trying to be thorough and make sure you get what I'm saying here about which two interior angles we're talking about. So I hope that you get it. If not, you know how to contact me. My students who are enrolled in my classes, I'm erasing that, okay? Cause I don't like the way that look. Alrighty. So again, folks, yeah. Alrighty. So this is what the theorem says. The exterior angle of a triangle is equal to the sum of the two opposite interior angles, or the two remote interior angles. Those two interior angles that are the farthest from or non-adjacent to the exterior angle. Okay, and we're showing you here what that looks like. Okay, so hopefully that helps. All right, now remember, folks, that there can be more than one exterior angle shown in a triangle. So for instance, with that, yeah, I didn't want it to do that. So with that same triangle, if they extended out a different side of that, then this one would be your adjacent. This one will be your interior angle. I just want to show you real quick. This one will be your exterior angle. Not trying to take up a whole lot of time, but I want to be thorough in what I'm trying to show you. Okay, so if this was the side that got extended, forming an exterior angle that I'm showing you right now. Wow, did y'all really let me write exterior, interior? That's okay, because y'all know I'm not trying to write exterior, interior. You know I was trying to write exterior angle, but it's all good. Maybe some of you didn't know I was trying to write exterior angle. That's why I'm correcting it. Alrighty. So again, that forms an exterior angle like that. So if this was the extended side that formed this exterior angle, then the two interior angles that would be considered your two opposite interior angles, or your two remote interior angles, would be these two angles right here. These two interior angles would be the two angles that are the farthest from, or that are non-adjacent to this exterior angle. If you get my drift, if you get what I'm trying to say here, and I really hope that you do, okay? Because I've taken up minutes of video time trying to make sure that you get it. But again, I hope that it helps clear up what we're saying, or that it helps bring clarity to it. Okay, all right. So again, these right here would be considered your two opposite or remote interior angles. Just to show you, okay? Or your two remote interior angles, okay? All right. So I do hope that makes sense. We're gonna look at some other relationships that exterior angles have. So again, this particular theorem it relates the exterior angle to those two opposite or remote interior angles. Another type of relationship that, and I'm going to erase this thing here. Another type of relationship that exterior angles have, guys, is okay, yeah, we glitching here. Yeah, all right, that's better. Okay, yeah, we glitching. Hold on 1 sec. All right, so guys, here's some more information about exterior angles. So guys, we had already talked about the exterior angle theorem, which again pretty much states that the exterior angle for a triangle is equal to the sum of the two opposite or remote interior angles. Is equal to the sum of those two non-adjacent interior angles. But some other information about exterior angles. Guys, the sum of the exterior angles of a triangle, and really, guys, so if you're seeing right there where I've got my mouse pointer, okay, you see that where I got my little circle, you see that right there, where I got that thing right there, the sum of the exterior angles of a triangle, and guys, not only just of a triangle, but for any polygon. The sum of the exterior angles of any polygon is going to be 360 degrees. So guys, when you take all of the exterior angles for any polygon, for any type of polygon, we know that the triangle just so happens to be the smallest type of polygon. But for any type of polygon, when you add up all of the exterior angle measures, it is going to be equal to 360 degrees. Because again, folks, we have mentioned before that again that all the angles, or when it seems like all angles are sort of kind of going around in a circle, and guys, all three of those angles would sort of kind of go around in a circle. If you get my little drift there, right? Part of it would be like that. That other part that you're seeing would sort of kind of be like that, and then this part right there would be like that, right? Like Y, X, and Z. You get what I'm saying? But anyway, for any polygon, and I'm about to erase this little circle thing that I just put there, but for any polygon, the sum of those exterior angles, the sum of all of your exterior angles for any polygon will be 360 degrees. Okay? I'm erasing this part right here because I don't really like the way that look. Yeah, I'm erasing it, getting rid of it. Bye-bye. I'm not talking to y'all, my students who are watching. I'm just saying bye to this stuff that I'm erasing right here. Alrighty. Because I don't like the way that look. But anyways, folks, yeah, I got to erase that too. I don't like the way that look neither. Not even you. Nope, you got to go too. Bye. Bye. Alright, there we go. Alright, so again, the sum of the exterior angles of a triangle, or for any polygon, the sum of the exterior angles is 360 degrees. Guys, also, okay, so y'all see that right there? What I got selected right there? You see that? You see that? You see the text that I got selected? Also, it's got a big, in all caps, also, you see it, you see it. Also, folks, an exterior angle always forms a linear pair with its adjacent interior angle. So guys, whenever you got an exterior angle, like what you see right there, you see that exterior angle? Yeah, good, I'm glad you see it. You see it in the diagram that I got over here to the right, that little orange part right there? So the exterior angle will always form a linear pair with its adjacent interior angle. You see that part that I got in blue over here in this diagram? Great, I'm glad you see it. Awesome. So guys, the exterior angle will always form a linear pair with its adjacent interior angle. And folks, remember that when you have a linear pair, two angles that form a straight line, like those two angles do. When you got two angles that form a straight line, folks, remember that again, that those two angles that form a straight line, they're called a linear pair. And any linear pair, all linear pairs, add up to 180 degrees. And any linear pair is supplementary. And they add up to 180 degrees for a linear pair. Don't forget that, folks. Because again, we've got these two angles, the exterior angle there and the adjacent interior angle for that exterior angle. They form a straight line. Okay, a straight line. I'm going to erase this straight line right here that I'm putting right there. But they form a straight line. Okay? And so again, that straight line that they form, okay, I'm going to show you one more again. They form that straight line right there. And I'm about to erase it again. Okay? And any straight line is 180 degrees. So again, folks, those two angles, the exterior angle and its adjacent interior angle, okay, for the triangle, those two angles will always be supplementary because they're technically a linear pair, and again, those two angles will add to 180 degrees. Alrighty. So, guys, those are the types of relationships that we get from exterior angles of triangles. Okay, so now, folks, now that we have discussed these different types of relationships that exterior angles have, or at least that when we're talking about the exterior angles of a triangle, because that's specifically the polygon that we're talking about right now is for triangles. Even though we do have exterior angles in other polygons, right now we're talking specifically about exterior angles for triangles. Now that we've discussed what types of relationships exterior angles have, guys, we're going to look at some examples to show you. Now, guys, some of these examples are gonna have only numbers in them where we'll literally only look at finding missing angle values or missing missing parts based on just numeric values. And then other examples that we look at are going to have variable expressions. Okay, expressions involving variables where we got to solve for an actual variable as well. We'll probably have to set up an equation and solve for that variable. Okay, all right. So let's go ahead on and look at these examples. Up next, coming right up. Okay, so folks, let's go ahead on and look here at these examples. Let's start with example 1. Okay, so for example 1 here, we've got this diagram right here. You see it. We got this diagram here, and they say find the measures of the 3 interior angles, and of course they're talking about angle 1, angle 2, and angle 3. So find the measures of those 3 interior angles, and you see that in all caps, and find the measure of the exterior angle. And of course they're talking about angle 4. Alright, so they want us to find the measure of all of those numbered angles. Find the 3 interior angles and those measures, and find the measure of the exterior angle. So guys, with a problem like this, first off, you see here, man, what in the world, Mr. Turkey? They didn't give us any of the interior angles. When we did our previous video with the triangle angle sum theorem, if we had 3 angle measurements or 3 interior angle measurements that we knew, like 92. I'm just saying if they were interior angle measurements like 92, 33 or something like that, or we could figure out what the 3rd angle measurement was, because now folks, what I'm reminding you of before was what we had previously talked about in our most recent lesson, okay, with the triangle angle sum theorem, talking about the 3 interior angles in a triangle and how the 3 interior angles of a triangle add to 180 degrees. Of any triangle add to 180 degrees, right? That's what we talked about in our most recent lesson and most recent video. Now, guys, that information is still going to be used here, but again, folks, is going to be used also with the new information that we just shared with you about exterior angles too. But again, three interior angles of any triangle always adds to 180 degrees. We'll use this info right here, but again, we'll also use the info that we just now shared with you. Alright, so again, that thing there that we discussed in our previous lesson is still true, and we still need to know that. Okay, so that's your reminder about what we talked about in our previous lesson. Okay, that 3 interior angles of any triangle add to 180 degrees. The 3 interior angles of any triangle add to 180 degrees. Alright, there's your reminder. Alright, we're going to go ahead on and erase all of that right there. Erase all of that right there. Okay, that was your reminder about what we talked about in our most recent video. Let's go ahead on and get this example worked out here. Okay, so folks, boom, 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 boom. Alright, so let's work this out here. Alright, so folks, we've got 2 exterior angles that we've got here. So let's say that we wanted to just kind of deal with this exterior angle and use this exterior angle to figure out some more information about our diagram, right? So with that exterior angle, okay, I'm trying to make it look similar to the diagram. There we go. Okay, that exterior angle gets formed by this side of the right triangle and an extension of this other side of this adjacent side of that triangle. And I hope I didn't say right triangle, because I didn't mean to say right triangle. But yeah, anyway, So we see this exterior angle here, okay, of 92 degrees, and we see how that exterior angle is formed by this side of the triangle and then this other side being extended out here, okay. And so, folks, this angle, this exterior angle, and its adjacent interior angle, right? So you see this exterior angle and its adjacent interior angle, okay? All right. So this exterior angle and its adjacent interior angle, they form a straight line. They're a linear pair. This exterior angle and its adjacent interior angle. I'm writing this so that nobody is confused about where we're going to get the measure for angle 1 from, okay? So excuse me while I write this, y'all, because it's more than me just working it out. You need to be able to understand what I'm doing. So I need for you to get every little step that I'm doing. So give me a... So again, folks, that exterior angle, 92 degrees, and its adjacent interior angle, angle 1, we're talking about the adjacent interior angle to that exterior angle, 92 degrees. Those two angles form a linear pair. They form a straight line. So again, they're a linear pair, which means that they are supplementary, which means that they add to 180 degrees. So, folks, if we know that those two angles, 92 degrees and the angle 1, add to 180 degrees, we can easily figure out what angle 1 is, because guess what? 92 plus 88 degrees equals 180 degrees. So that means that angle 1, or the measurement of angle 1, has to be equal to 88 degrees, right? Because again, that's the only way it works for those two angles to add to 180 degrees. 92 plus 88 equals 180 degrees, right? Great, awesome. So we know what angle 1 is, okay? Based on that, angle 1 has to be, and again, we could write out a little thing there. Again, 92 plus the measure of angle 1 has to be equal to 180, right? We can write out a little angle addition with that. And so again, folks, if we solve it, we get, yeah, y'all know, because we've done this before, okay? This here shouldn't be new, okay? To you. Now I'm talking to my students who are enrolled in my classes at our school, right? This shouldn't be new, okay? Doing what I'm talking about right now. Alright, so again, the measure of angle 1 is 88 degrees. And folks, we can do the same thing with angle 2. So we can do the exact same thing with angle 2 because angle 2 also has angle 2, or we can do the same thing with the exterior angle 123, because it has an adjacent interior angle that we can go ahead on and find the measure of. So let's go ahead on and do that as well. So same thing here. This exterior angle, the 123 degrees, for the same reason, the 123 plus the measure of angle 2. And I apologize if this starts to look jumbled up, guys, but we want to make sure you get how we're getting each part of this, how we're figuring out each part of this. So again, that 123 degrees plus the measure of angle 2 also has to be equal to 180 degrees. So again, when we solve for that and we subtract 123 from both sides of the equation, we have to get that the measure of angle 2 is 57 degrees. So again, folks, the measure of angle 1 is 88 degrees. The measure of angle 2 is 57 degrees. Because again, that exterior angle and its adjacent interior angle, again, the 123 degrees and its adjacent interior angle, angle 2, they form a linear pair, a straight line, which is supplementary or adds to 180 degrees. So it's that reasoning, okay? And that's how we were able to get angle 1 and angle 2. Okay, so now, folks, now we know 2 of our interior angles in that triangle. So now, folks, we're going to go ahead on and find our third interior angle for this triangle. So again, now that we've got this two of the angle measurements, let's go ahead on and put together what we've already found, right? So now we've got this triangle here. Okay, I know that's sloppy, y'all. Y'all have to excuse me on that one. But a little bit better. There we go. Look at there. Okay. Alrighty, so we got that triangle right there. And we had already found that the measure of angle 1 was 88 degrees. And we had found that the measure of angle 2 was 57 degrees, right? So again, folks, we're using what we know to find out the parts that we don't know. And that's the way that it works. We're using logic and the basic knowledge that we do know to figure out things that we don't know. Okay, that's what we're doing. All right, and again, I'm trying to break it down step by step for you. Okay, all right. So we need to figure out what angle 3 or what the measure of angle 3 is here. All right. So folks, in order for us to figure out the measure of angle 3. Yeah, I thought that was going to be more like a rectangle. Y'all, hold on one sec. Let's see if we can make that look more like a rectangle. Hey, there we go. That's better. All right, so in order for us to figure out the measure of angle 3, again, folks, the 3 interior angles for a triangle they always add to 180 degrees. So, folks, I've already written that out for you in a previous lesson, and I even wrote it out momentarily a few moments ago before we really begin working this example out, and we did it in the previous lesson, so I'm not going to write it out again. But again, folks, we know that these 3 angle measurements, the 3 interior angles, that those 3 measures add up to 180 for any triangle. So 88 degrees plus 57 degrees plus the measure of angle 3. All 3 of these interior angles for this triangle, they have to add to give us 180 degrees. And again, folks, that's what we talked about in our most recent lesson. So this shouldn't be new for you. My students enrolled in my classes at our school. This here should not be new for you. When we solve this, let's add 88 plus 57. We get 145. When we combine those two constant terms. Yeah, folks, we really don't have to put those angle those degree symbols there in this equation. All right. So again, we know that's 145 there, plus the measure of angle 3 equals 180. And so then when we subtract 145 from both sides, guys, we get that the measure of angle 3 has to be 35 degrees. All right, so there we go. Now we've got the measure of all 3 of those interior angles. Wow, that's sloppy. Oh, but they fixed it. All right, so now we got the measure of all 3 of those interior angles. Those 3 interior angles, angle 1, angle 2, and angle 3. Now, folks, we just need to figure out what is the measure of our exterior angle. All right? So, if we're going to figure out the measure of our exterior angle, let's use what we know about exterior angles. All right, so the easiest way for us to do that is to hold on real quick. I'm gonna separate this. Give me one sec, because I don't want it to be jumbled up. And folks, we're still on the same example, but that's okay, because I wanted to work it out and show you each step of it. I apologize for those who might be impatient about us still being on the same example. Okay, but again, we're explaining this to you so you know how we got each part of this. All right, I'm gonna separate this out so it doesn't look so jumbled up. Okay, so folks, for the last part of this example, we need to find the measure of that exterior angle, angle 4. And so, folks, if you follow along here with the green, that really, really long green arrow, you see that? That's coming all the way over here on the right side. Great, lovely. Glad you can follow that green arrow all the way over here. All right, so, if we look at angle 4, and if we look at those 2 opposite remote, and again, those 2 opposite interior angles, or those 2 remote interior angles, or those 2 non-adjacent interior angles that are the farthest away from this exterior angle, angle 4 right there. So again, if we look at the relationship between the exterior angle and those two remote interior angles, the exterior angle there is supposed to be equal to the sum of those two remote interior angles. And again, folks, we've discussed this a little earlier in this video, in this lesson. Again, that the measure of the exterior angle is supposed to be equal to the sum of the two remote interior angles. And so, folks, what that means is, if we write out a little equation based on that knowledge, the measure of angle 4 is supposed to be equal to the measure of angle 1 plus the measure of angle 2. And this is again still using that angle addition, really, but it's not exactly in the same context as when we first looked at the angle addition postulate. But again, all right. So again, if we write out that representation, again, the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Well, guess what, guys? We had already found the measure of angle 1 and the measure of angle 2. The measure of angle 1 was 35 degrees, and the measure of angle 2 was 57 degrees. So 35 plus 57 gives us 92. Great. So now we know exactly what this exterior angle is. Okay, wait, did I write the wrong thing? I think I did. My bad. Hold on. I didn't mean... Nope, I sure didn't. I did not mean 35 degrees, because that's not the measure of angle 1. My bad. The measure of angle 1, guys, is 88. Alright, so again, the measure of angle 1 is 88 degrees. Alright, and so if we add these two angle measurements together, the measure of angle 1 plus the measure of angle 2, 88 plus 57 gives us 145. Alright, so guys, the measure of angle 4 has to be 145 degrees. Alright, and now, folks, we have found all of the parts that they have asked us to find. The measure of those three interior angles, angle 1, 2, and 3, and the measure of that exterior angle that we didn't know, angle 4. So, guys, that's the first example. We're going to look at some more examples. Now, again, folks, this example was only had numeric values. You didn't see any variables like X, Y, Z, Q, R, P, S, T, whatever. You didn't see any variables at all. There were only numeric values here, okay? But again, folks, this example still involved even some of those previous concepts that we had been discussing. It didn't only involve concepts with just exterior angles. It also involved things like linear pairs, right? It involved things like linear pairs that we had talked about in previous lessons too. But anyway, that's example 1. Folks, we're going to look at some more examples with adjacent angles. And some of these next examples are going to have variable expressions in them. All right, folks, the next example is coming right up. All right. Okay, I'm sorry about that. I didn't mean to steal that from Kevin Hart. Okay. Anyway, example 2 there. So in example 2, we've got this triangle. They've given us here. You see in this diagram, they've given us the measure of one of these exterior angles, and that angle there, that angle measurement is 146 degrees. So they say here, in triangle ABC, by the way, guys, if you didn't know what that symbol means, sometimes they will they'll instead of writing out the word triangle when they're naming a triangle, and sometimes instead of writing out the actual word triangle, sometimes they'll use that symbol that literally looks just like a triangle. Y'all see the symbol? You see it? That symbol there that looks exactly like a triangle? Yeah. Yeah. Sometimes they'll use that symbol to name a triangle, okay? Instead of writing out the word triangle. Okay, so instead of writing out the word triangle ABC, they'll use that symbol there that looks just like a it look just like a triangle, don't it? All right. I'm glad we agree on that. All right, so again, folks, in triangle ABC, find the measure of angle A and find the measure of angle B. So, folks, if that's what they want us to do here, then the simplest way, the easiest way for us to do it is, again, folks, for us to realize that exterior angle, the measure of the exterior angle that we've got is equal to the sum of the two non-adjacent or the two remote interior angles. Is just that case. Okay, it's just true. It's equal to the sum of the two remote opposite interior angles, whatever you want to call them, opposite interior, remote interior, non-adjacent interior. You know, I mean, it is what it is, right? You know, I'm just saying, you know. All right, so it's equal to the sum of the two opposite interior angles. And so, again, folks, what we know is that, wow, yeah, I thought that was going to look a little bit better than that. Still don't look quite as good, y'all. Give me just one sec here. Alright, a little bit better. That's a little bit better. Ain't much better, but a little bit. Alright, so folks, what we know is that they're talking about they're talking about that 146 degrees for that exterior angle, right? So they're talking about that 146 degrees, and it's equal to the sum of the two opposite interior angles, or the two remote interior angles. And so they're talking about the measure of angle A, and we know that angle A is this angle right here, and I'm going to erase that. So we know that the angle A is that interior angle, right? So they're talking about the measure of angle A plus the measure of angle B. And again, folks, they're talking about for angle B, that they would be talking about this interior angle right here that I've got marked. So they're talking about these two interior angles that I've got marked with green on the diagram. But again, I'm about to erase that. Okay? Alright? Okay. Alright. So we got 146 as the exterior angle. That measurement is equal to the sum of the two opposite interior angles, which is the measure of angle A plus the measure of angle B. And so, folks, in the diagram, they've got it that the measure of angle A is 5y plus 3, and they've got it that the measure of angle B is 4y plus 8. So 146 degrees is equal to 5y plus 3 plus 4y plus 8. Okay, and so again, that's using that exterior angles theorem, which again only applies to triangles. So again, folks, we know that that's true. Yeah, when we got an exterior angle for a triangle. All right, so let's work this out. Let's solve it out. I'm not going to take up video time solving this out, because by now, folks, we should know how to solve this out. And I'm fairly confident that all of my students enrolled in my classes at our school know how to solve this equation. But again, if you don't, feel free to contact me if you need some help with anything, not just this lesson, anything. Feel free to contact me, because my students enrolled in my classes at our school have my contact information. Alrighty. Alright, we're not going to show solving this out, but we're just going to show you the answer. Alright. So, guys, y equals 15. Y equals 15. Guess what? We ain't done yet. We ain't done yet, right? Pay attention to what they asked us to find. They didn't ask us to find y. They asked us to find the measure of angle A and the measure of angle B, right? Right? Okay. So again, now, folks, we couldn't find those two measures that they're asking us about, the measure of angle A and the measure of angle B. We couldn't find those unless we did what we just did first anyway. So guys, even though we had to find out what the value of y is, that's not the end of this problem. We're not done with the problem until we find what they've asked us to find. All right, so for us to figure out what the measure of angle A is, we have to plug it into that expression. And so again, folks, the measure of angle A just so happens to be, give me just 1 second, y'all. I got to split this up. I ain't got to split it up, but I'm about to. We ain't done with the problem yet, y'all. I don't want it to be all jumbled looking, all right? All jumbled up looking. All right, so again, the measure of angle A is 5y plus 3. And again, folks, if we want to find out what that measure of angle A is, we need to plug in the value of y that we just now got. So we plug in 15 for y, and we get here 5 times 15 is 75, and 75 plus 3 is 78. So the measure of angle A is 78 degrees. 78 degrees. Yeah, baby. 78 degrees. Yeah. 78 degrees. All right, the measure of angle A. All right, so that's one part of what they were asking us to find. The measure of angle A is 78 degrees. Folks, we got to do the same thing to find the measure of angle B. We got to plug in that value so we can find the measure of angle B. Okay. So the measure of angle B, they said that that one, or the variable expression for that one, was 4y plus 8. And again, folks, if we're going to find that measurement, we've got to plug in the value of y that we found. So here, this is going to be 4, give me 1 sec. That is going to be 4 times 15, which is 60, plus 8. So guys, 60 plus 8 is 68. So the measure of angle B is 68 degrees. The measure of angle B is 68 degrees. And so now, folks, we have found those two measurements that we were asked to find. The measure of angle A is 78 degrees, and the measure of angle B is 68 degrees. Alright, and so guys, let's just verify our findings real quick with those two. Alright, so that third interior angle formed real quick. That third interior angle forms a linear pair, forms a straight line with the exterior angle that we've got there. Forms a linear pair with that, right? So that means that these two angles here are supposed to add to 180, which means that something plus 146 has to add to 180, right? So that means that this third interior angle would have been 34 degrees. The third interior angle there would have been 34 degrees. So let's check it out. Let's make sure that that works. With all three interior angles, let's make sure that this works. The measure of angle A being 78 degrees. The measure of angle B being 68 degrees. And that third interior angle that we technically were not asked to find was 34 degrees. Let's make sure that that actually makes sense and make sure that it works. 78 degrees plus 68 degrees plus 34 degrees. Does it actually add? Do those three interior angles, do they add to give us 180 degrees? Do the three interior angles of this triangle add up to give us 180 degrees? Well, that's a great question. 78 plus 68 gives us 136. Sorry, 146. All right, and 146 plus 34. Well, looky what we got here. It sure enough do, y'all. All three of these interior angles sure do add up to give us 180 degrees. Y'all, you know what? Those two angle measurements that we found sure enough is right. They right too. They ain't wrong neither. Alright, I'm gonna erase this. Alright, but again, those two angle measurements that we found for measure of angle A plus the measure of angle B are correct. We're gonna look at least one more example, folks, with that's dealing with variables. At least one more example with this. Okay. All right, so guys, here we go. Example 3 with these problems dealing with the exterior angles and triangles. So for this example here, they're asking us to find the values of all the variables. And so now, some of you guys might be looking at this diagram and you might be saying, no, Mr. Starkey, why would you do that? Why would you do that? Yeah, so folks, yeah, I get it. This diagram right here, it sort of looks like it's on steroids compared to the other two examples that I just showed you. I know, yeah. But I promise I'm not gonna leave you hanging. I'm gonna break down each part of what we're doing, okay? All right, that's a promise, okay? Because there ain't no need of me making this video if I'm not gonna break it down and explain it to you. All right, so. Alright, let's do this. Let's get to breaking down, folks. Alright, so so guys, in this diagram, they got 4 different variables. They got a variable x. They got a variable for oops, I ain't mean to move that like that. They got a variable for y. They got a variable for w, and they got a variable for z. Okay, so they got 4 different variables. But looky here, that variable for x. They got how many angles that are involving the variable x? This one. Okay, this angle involving x is one of the exterior angles. This angle involving x is not one of the exterior angles, but it's technically on the outside of the triangle, but it's not an exterior angle. And this angle for x is one of the interior angles of the triangle. So we got 3 different angles in this diagram that have the variable x. Now, folks, they don't give you any numeric values. If I were gonna even remotely even try to do anything with this diagram to figure something out, I would take a close look at those three variable expressions that include x. Okay? Yeah, because I mean that can't be a coincidence that they got these 3 different parts that all 3 have the variable x, right? Okay, so if we take a closer look at that, folks, let's see here. Boom. Look at that. Alright, if we take a closer look at that right now. Let me see where I want that at. Y'all give me a check here. Give me a check. Alright, so folks, again, we're going to take a closer look at those 3 variable expressions that have the variable x in there. Because again, folks, that can't be a coincidence, you know. I'm saying, you know, I'm just saying, man. You know, hey, man. I like how to do that right there. Okay, I don't even know who that was. I mean, Chingy, I don't even know who that even is, you know. I'm just saying. Alright, let me see, okay. Alright, those three variable expressions that have x in there. Okay, yeah, there we go. Alright, so at those 3 right there, right? So folks, if we look at and focus on these 3 expressions, and first off, guys, let me kind of just go ahead on and just do this here, okay? Alright, so we know that this one that was right there is the exterior angle, okay? Wonderful, right? Okay, yeah, I don't like the way that there even look, not even, that's okay. Alright, hold on, yeah, that's better, a little bit, only a little bit. Alright, so that angle there, the one that said 2x plus 26, that one was the exterior angle, okay, out of those 3 angles, right? Okay, So of course this angle that was in here, the 3x minus 50, of course, guys, that was one of your interior angles. And then, folks, this angle up here at the top, I want to kind of focus on that angle up there at the top real quick. That angle at the top, if you look at the way that angle at the top is formed, that angle at the top up there that says x plus 10, right? That angle is a vertical angle. That angle right there is a vertical angle with one of the interior angles of that triangle. Right? Y'all see that? These two angles right here, that one and this one, those two angles right there, that one and this one, you know which two angles I'm talking about. Don't act like y'all don't know what I'm talking about. These two angles right here. Those two angles are vertical angles. And so, folks, if they're vertical angles, that means that they're congruent, because all vertical angles or all pairs of vertical angles are congruent to each other. And if they're congruent, that means that they have the same measure, right? So they're vertical angles, which means that they're congruent. And if they're congruent, that means that they got the same measure, right? All right, so folks, in other words, if that one at the top was x plus 10, that means that this one at the bottom has to be the exact same. They've got to have the same measurements, the same measures. If they're congruent, like vertical angles are, they got to have the same measures. So if that angle at there is x plus 10, then this angle down here has to be x plus 10. I hope that makes sense. It's got to make sense, right? Based on everything that we've already talked about. Yeah, it needs to. All right. So, again, folks, that means that angle right there, this exterior angle, that angle has to be x plus 10. So, folks, if that is the case, and now if we know again that this one here was an exterior angle, the 2x plus 26, right? This angle here is this interior angle, what we just discovered, because it's a vertical angle with that one. This interior angle is the same as that other angle that was technically outside of the triangle, but that's technically not an exterior angle. So this interior angle at the top there is the same as that one, that x plus 10. And I apologize if this looks sloppy or jumbled up there. But again, just trying to show you and explain what we's doing. All right, so the exterior angle was 2x plus 26. This interior angle at the top technically is x plus 10, and this other interior angle right here at the bottom on the right side was 3x minus 50. So guys, those two interior angles there. Let's see. Let's pick a different color. Those two interior angles that are right here, the x plus 10 degrees. Okay, I thought that was gonna do my little do me like a little box, but yeah, it might not do it. It's okay if it don't. Hey, it did it. All right. All right. Okay now. Yeah, that's what I'm talking about right there. Yeah, that's what I'm talking about. That's what I'm talking about. You know what I'm trying to say right there, boy. Okay. All right. Yeah. Alright, yeah, that's a clear indication that Mr. Starkey is tired. Yeah, if I'm rambling on like this. Okay, anyway, folks, tired doesn't matter. Let's finish going through this here. These two angles that I've just now put in sort of like orange boxes, those two are our remote, our two our two remote interior angles here. So again, folks, we've got that exterior angle, this one right here, that is the 2x plus 26, and then we've got our two remote interior angles right here. And we should know what the relationship is between that exterior angle, the one that says 2x plus 26, and what the relationship between that and these two remote interior or two opposite interior angles are. Because, I mean, hey, that's only what we're talking about in this video, right? Alright, so again, folks, the relationship between that and the way that we're going to solve for x is by doing what we did in the previous examples, really. I mean, now that we got what we got, right? Now that we know, again, that your exterior angle, or now that we know we have identified those particular parts as what they are. And so again, folks, we know that the measure of the exterior angle is supposed to be equal to the sum of the two remote interior angles. Okay. Of the two remote or opposite or non-adjacent interior angles, right? Alright, and so again, folks, we know that this right here is true. It's true. This relationship is true whenever we've got an exterior angle for a triangle. Alright, so let's go ahead on and work this out and find what x is using this information. Let's do this. Alright, so let's set up our equation using what we already know. Again, folks, the equation there, that exterior angle was 2x plus 26. The interior angle, or those two remote interior angles that we've got to add together, the sum of them is x plus 10 plus 3x minus 50. And so, guys, we've got our little equation set up based on this relationship. Alright, so again, I'm not going to take up video time solving for x. Just going to show you the answer. Alright, so folks, x here is equal to 33 degrees, and that's one of the variables. Remember, folks, we have 4 variables altogether. And so, folks, the next logical thing for us to do, now that we have solved for x, and hold on real quick, give me 1 second, I gotta make sure I'm still recording. Okay, gravy, good. Alright, I'm still recording, great. Alright, so the next logical thing for us to do now that we have found x, guys, is to plug in that value of x. And folks, that is what we're gonna need to do. And guys, I literally suggest plugging in that value of x everywhere in that diagram. So again, folks, I'm going to plug in that value of x because in our diagram, and let me explain why we're going to plug in the value of x. First off, in the diagram, we've got these different angle pairs that form linear pairs. So we've got this angle here that says x plus 10 that forms a linear pair with this angle that has z in it, right? So if they form a linear pair, that means that the total measurement for them is 180 degrees, right? Great, lovely. So what we need to do is we need to plug in the value of x there. That'll tell us what that angle measurement is there at the top. And then we can use that to figure out what z is. You get what I'm saying? Do you feel me? You feel me? You feel what I'm saying here? And then, folks, it works the same way. We've got this angle, these two angle pairs down here that are also forming a straight line that form a linear pair. They form a straight line, they're a linear pair, and their measurements add to 180 degrees because, again, they're a linear pair. So, folks, we're going to need to plug in the value of x into this variable expression, 2x plus 26. And again, folks, when we do that, that'll tell us what the measurement of that angle is. And then, folks, excuse me, I didn't mean to move that. And then, folks, we can use that to find out, to solve for y. And then again, folks, right here, we've got these two angles that are coming together to form a linear pair, a straight line. And again, folks, because they are forming a linear pair like this, they form a straight line. They're supplementary, and they got to add to 180 degrees. So again, folks, all of these ones that I showed here that I marked in blue, those two angles that I've done there, they're linear pairs, a linear pair, and they're supplementary, and they're adding to 180, adding to 180 degrees. Okay, I'm just going to write supplements for right now. The two angles that form a linear pair are supplements, which means they add to 180 degrees. So again, but again, before we actually use what we just now talked about as far as those linear pairs, before we use that information, we need to plug in our value for x into all of those variable expressions that have x in there. And so that's what we're going to do right now. We're going to plug in the value of x here, all right, into all three of those, and then we'll solve what we need to solve there. All right. So let's plug in the value of x there, so we can figure out all three of those angle measurements that have x in there. All right. So let's do this. Yeah. Plug in the value of x. We'll put it that way. That's the only way to put it, really. Plug in the value of x. Alright, so if we do that for all three of those things, for all three of those angle measurements, we had the x plus 10. Yeah, I don't want to put that way over there because I still want room to finish doing what we got to do for the rest of the variables. Alright, so x plus 10, if we plug in our value of x, 33, I'm going to zoom out on this sum. Hopefully it won't make it too small when you can't see what I'm writing, but yeah, I need the space here. So if we plug in our value of x here, that is 33 plus 10, which gives us one of those angle measurements as being 43 degrees, because again, that angle measurement was 43 degrees. So this one is 43 degrees. Yeah, I really don't want to do it like this, but I kind of got to. So y'all have to excuse if it looks sloppy. Please excuse it. Please excuse my dear Aunt Sally, even though my dear Aunt Sally, I ain't got one, ain't really here right now, and that's fine. But anyway, folks, hold on. Let me do it like this. Put an arrow there. So this angle measurement right there is 43 degrees. Good. Lovely. Awesome. Brilliant. All right, that angle there is 43 degrees. Yeah. And so that was us plugging in x into that one. Give me 1 sec, y'all, to separate this. All right, so folks, yeah, we had to kind of separate that stuff out. So it, even though it does look kind of jumbled up, so it doesn't look too jumbled up. So again, folks, after we plug in the value of x into those three variable expressions, we get that the measure of those three angles were 43 degrees. You see that? 49 degrees. You see that? Okay. And 92 degrees. Okay. So the measure of those three angles there that had the variable x were 43, 49, and 92 degrees. So folks, we need to the best way for us to figure out the value of the other variables here is to go ahead on and use what we said about those linear pairs and go ahead on and do that. So if we use what we know about the linear pairs, about all three of those linear pairs that we've got, again, folks, I don't have a whole lot of space here. I'll try to write what I can out about these. But again, folks, if we're going to use that about the linear pairs, the fact that they add to 180 degrees, if we're going to use that, and we are, by the way, going to use that, then we can set up three different equations to help us figure out what y is. So again, the equation that help us figure out what y is would be the 8y plus 92 degrees. So again, these two angles, the 8y and the angle that we just found was 92 degrees by plugging in the value of x. Those two angles have to add to 180 degrees. Okay. Give me a sec. I'm gonna split these up after I write them out. And the other equation that'll help us find z is 2z minus 43 plus 23 minus 43 plus 43 equals 180. And then the third equation that'll help us figure out what w is 3x minus 50 plus 49 equals 180. Now again, folks, I'm about to split these three up so that they don't look quite as jumbled. Give me a sec here. And actually, guys, before I split this up, why didn't y'all tell me I wrote the wrong thing? I mean, anyway, you probably noticed it, but it's all good. All right. So again, for this last equation that can be set up to help us find out what w is, this one will be 4w plus 11 plus 49 equals 180 degrees. Now I'm about to split these three equations up so those three don't look quite as jumbled. Okay, so folks, now that we've got those three equations over there in blue kind of split up, kind of sort of separated, where they don't look quite as jumbled. Again, we'd have to solve those three equations. And again, we got those three equations because again, guys, we have three sets of linear pairs that I've marked on the diagram with blue. So hopefully that makes sense to you. I apologize about maybe how jumbled up this looks, but again, folks, like I said, we want to make sure that you get where we're getting each part from. So yeah, that's what we're doing here. All right, so if we solve this one here, subtract 92 on both sides. Yeah, I might not even have enough space to even do that, but it's all good. Gonna do that real quick. That gives us 88. And so 88 equals 8y. And y, once we divide by 8 on both sides, y equals 11. So folks, that is what y is equal to. Yeah, and I hate the way that looks right there. So give me 1 second. That's better. Y is 11. Over here, if we combine these two terms, those two constant terms on the left side, negative 43 and positive 43, technically those two cancel each other out. Or they add to give you 0, but technically they also cancel each other out. Negative 43 and positive 43 are additive inverses that add to cancel out and give you 0. So on the left side, we've got 2z left over. And here, 2z is equal to 180. Divide by 2 on both sides, and z equals 90 degrees. Sorry, well, not degrees, but z equals 90. All right, and then the last thing there with solving for w. we've got that equation based off of that linear pair in the diagram. But again, if we combine the like terms there, 11 and 49 combine to give us 60. And then we still got 4w plus 60 equals 180. And then, folks, we'd have to subtract 60 on both sides. When we subtract 60 on both sides, we get 120. Then we'd have to divide by 4 on both sides. When we say 120 divided by 4, we end up getting that w is 30. So, folks, as of right now, we have solved for each variable, and that would be the end of this example. Guys, just a brief little walkthrough of everything that we did in this example. First off, guys, we focused on the variable x, on those three expressions that had the variable x. That part right here, that said 3x minus 50. This part that said 2x plus 26, and this part that said x plus 10 there. We focused on those three parts because we realized that was the exterior angle, and those other two angles were the remote interior angles for that exterior angle. And they all had the same variable x. So we set up an equation using that relationship, and we solved for x. Then, guys, after we solved for x, we plugged in that value of x into those three expressions. We plugged in that value of x into those three expressions, and we got that one of those expressions had to be 43 degrees right there. And we got that another one had to be 49 degrees right there. And we got that the other one had to be 92 degrees. Okay, great. Right there, right? So then, folks, we did those three linear pairs that were in the diagram. And again, we know that because they formed a linear pair, they were supplements of each other, those two angles that form a linear pair. And so we set up those equations and we solved for those other variables. That was example 3. Guys, the only other thing that I really need to show you in this video is how your practice problems are going to be set up and are going to look on Delta Math. I'm talking to my students enrolled in my classes at our school. This is important because, again, folks, the practice problems that I've got for you for this lesson on deltamath.com are going to be sort of set up as word problems, and I need to show you exactly how you'll start off with doing that. If they're set up as literally all word problems where you won't have a diagram, I need to show you real quick how to read that word diagram and set up your diagram. And that's the only other thing that I'm going to show you with these next two examples. Because one example is dealing with what was in this lesson with the exterior angle theorem, and the last example that we're going to do is going to be dealing with what was in the previous lesson in our previous video on the triangle angle sum theorem. But again, folks, I want to show you very, very briefly how to do these types of Delta Math problems that'll be in today's lesson, in today's assignment, okay, that are set up as word problems. So just bear with me for a few more minutes as I show you this. All right, trust me, as long as this video is, it took me a whole lot longer to record it than it's taking you to watch it. Trust me, I guarantee you. I guarantee you. Watch the timestamp. But anyway, I'm not complaining. So let me show you real quick. All right. So, folks, your practice on Delta Math for today's lesson is going to involve two types of problems, and both types are going to be written as word problems. But again, one type is gonna be involving the exterior angles, and the other type is going to be involving the sum of the three interior angles. So again, folks, with this type here, well, let's read it and I'm gonna show you how to draw out your diagram. Now, once your diagram is drawn out correctly, I expect you to know what to do from there. So I'm not going to finish working this out because we've already done 3 examples here with this to show you that All right, so I'm not going to finish working this out for you because that's just going to take up more video time. All right, so it says in triangle TUV. Well, guess what, folks? Triangle TUV, that's pretty easy to draw out, isn't it? You draw yourself a triangle, TUV, and you label. It don't even matter which point, which vertex you label as T, U, and V. It don't matter. I could put T here, or I could put T there. It does not matter. As long as you label your 3 points of whatever type of triangle you draw. You could draw it as an obtuse triangle. You could draw it as an acute triangle. You could draw it as a right triangle. It ain't gonna matter. Just draw a triangle and label the 3 points in there. I'm just saying, okay? So there's triangle TUV. All right, so it says that segment TV is extended. So they're talking about this segment right here, segment TV. Yes, this segment over here, the way I've drawn it is this segment that's on the left side here of this triangle. You might not have drawn yours the same way that I drew mine, which is fine, but just make sure that you're paying attention to what they're saying. So they say segment TV is extended through. So it says that segment TV is extended through point V. So what does that mean? That segment TV gets extended when it says through point V. So not only is it going to stop at point V, but it's going to go right through point V. Looky there. Segment TV is extended through point V to point W. So you see how I've extended segment TV and I've extended it through point V. Did you guys see that? You saw it, right? Did you see it? I extended segment TV through point V, and I'm extending it to point W. Looky there. Huh. Y'all see that? That ain't hard, right? I drew a triangle. I labeled it. I labeled the vertices as what they said the vertices were. I identified which segment they were talking about, segment TV. I extended it through the point that they said to extend it through. All right, so I extended segment TV through point V, so it went past point V, and I extended it all the way to point W. That wasn't hard, was it? Awesome. Now, folks, the only other thing that you need to do is fill in this diagram with the variable expressions or with the numeric expressions that they tell you. So that's what I'm going to do here for you, okay? And then I'll go to the next example, which is slightly different, but still a word problem, okay? To make sure that you know how to draw out your diagram and where to start off with doing this, okay? Because it's the same type of examples that we've already looked at, except for the fact that they don't have a diagram drawn for you. They've got a word problem, and you got to draw the diagram for yourself, okay? But I'm showing you how to do it right here, okay? Alrighty, so now they said that the measure of angle VTU, So, folks, if you are not good at identifying angles, what I suggest you do, folks, is literally follow along those three angles. VTU, angle VTU. The only angle that follows along those three vertices, literally follow those three. If I go from point V to point T to point U, there's only one angle, and that angle VTU has the vertex. The vertex there is point T. For that angle VTU, the vertex is point T, right? So they're talking about that angle for angle VTU. You get what I'm saying? For angle VTU, they're talking about that angle that has a vertex of point T. So for those who might not be so good at identifying angles, I'm trying to break it down to you. Not that I haven't already in previous lessons, but I want to make sure that we make it real clear, okay? So angle VTU will be that angle right there. So angle VTU is this one that says, and they said the measure of that angle is x minus 2. Okay? All right, angle TUV. This one has the vertex of of U. Angle TUV should have a vertex of U. And again, folks, if you just follow those 3 points, T, U, V, literally, if you just follow those 3 points, T, U, V, and draw like you connecting the dots from T, U to V, T, U, V, you can see what the angle looks like. If you connect your vertices from T to U to V, you can see which angle they're talking about. Okay, so angle TUV has the vertex of where am I at? Has a vertex of U. Yeah, I thought I was erasing that. Give me a sec. I'm almost done, folks, and I'm just gonna show you finish showing you how to draw out this diagram and label it, and then I got one more different type that you'll need to label and draw out, okay? And then we're gonna call it quits, I promise, because I'm tired of making this video myself. If you tired of watching it, trust me, I'm tired of making it. Like I said, it's taking me longer to make the video than it's taking you to watch it, but I don't mind because it's meant to help you. So yeah, like I said, I'm not complaining. All right, so angle TUV has a vertex of point U. All right, so angle TUV, that was this angle right here. I'm gonna mark it a little bit different in red with the one that has a vertex of U, right? That one is 2x plus 11. All right, and then they said angle UVW is 6x minus 15. So again, folks, if you're not getting which one UVW is, I'm just trying to make sure that everybody get what's going on. So I'm sorry if I'm taking a little bit to do this, but I'd rather take the time to make sure that I explain it the way that I know that you can get it, that everybody should be able to get it. And again, if you can't get it based on the way I'm explaining it, or if you've already clocked out and tuned out, then feel free to contact me, because again, my students got my contact information. But anyway, angle UVW, if you literally follow along those 3 points for angle UVW and connect the dots from U to V to W, you can see what that angle looks like. Yeah, okay, I thought that was going to look a little bit better than that. Angle UVW is that angle right there, okay? So UVW clearly has a vertex of V, right? So angle UVW, where the vertex is V, is point V. Okay, yeah, I thought, yeah, never mind, hold on. Undo that. Where the vertex is V, all right, and they're talking about the and I know I drew that wrong, and I'm so sorry that I drew it wrong, folks. But again, folks, angle, and I realize that I drew it wrong. But again, angle UVW, if you connect the dots from U to V to W, is they're talking about that exterior angle there. Okay, so don't mind the fact that I drew it wrong over here. But again, folks, they're talking about that exterior angle UVW. Okay, yeah, and so that one is 6. Oops, thought I was writing it. That one is 6x minus 15. All right, give me 1 sec, folks. Let me make sure I'm recording, because I don't want to have to say all of this over again. Okay, great. I was recording. Wonderful, lovely, awesome. Okay, 6x minus 15. All right. So, folks, that is the way you would have to set this up. Again, folks, this is one of those problems that we went through where we've got an exterior angle and the 2 interior angles and the 2 remote interior angles. So again, if we had to put it all together, we got 6x minus 15, that exterior angle, and we got the x minus 2 right here as this interior angle. one of the two remote interior angles, and this part here, this angle, as 2x plus 11. So you got your exterior angle and two of the remote interior angles. All right, so we're going to look at one more example very, very quickly. Just going to show you how to set it up and how to draw out your own diagram. And again, the next example is not going to be one with exterior angles like this one that has an exterior angle. But the next one is going to have all three of the interior angles, and you're going to be asked to find something based on that. Okay, so very quickly, I'm going to show you the last example and how to draw out the diagram when it looks like that. When you've got a word problem that's asking you to do it like that. Okay, folks. This here's the last example. Again, folks, just want to. And these last two examples that were word problems, again, folks, these are the way that your problems will look on Delta Math. They'll be written as word problems, and you'll have to draw out your own diagram, your own triangle, and label it based on the description that they tell you. All right, so here's example 5, the last one, and then we're gonna call it quits because Anyway, all right. In triangle SAT, so again, folks, all you got to do is draw out any triangle. It doesn't matter how you make the triangle look, because you don't know whether the triangle you drawn is drawn to scale or not. It does not even matter. I'm gonna tell you, it don't matter how you make the triangle look, because you're gonna have to solve for the stuff anyway. So whether it looks like something that you want it to look like or not, it don't matter. Triangle SAT. Alright, so draw any triangle, a triangle, and label the three vertices, or the 3 points of it, as S, A, and T. Alright, and then, folks, since they tell you that the measure of angle S, now again, folks, if they just give you like something like the measure of angle S, the measure of angle A, and the measure of angle T, they're talking about these are the interior angles. Alright, and first off, and guys, you know that they're talking about the interior angles because you didn't have to extend out any of those sides. So because you didn't have to extend out any of those, yeah, okay, they know I wasn't trying to do that. Because you didn't have to extend out any of those sides, clearly here you don't have any exterior angles that they're trying to tell you about. So folks, here they're only telling you about the interior angles here. So the measure of angle S is 3x. Yeah, okay. Thought I was writing. Give me a sec. Measure of angle S is 3x plus 6. The measure of angle A is 2x plus 75. And the measure of angle T is x plus 9. Okay, so that's how you would draw out your diagram and label the parts that they give you with a question or problem that looks like this. Okay, again, here, guys, they're giving you the, wow, that looks sloppy, but you know what? It's gonna have to be okay. Yeah, that look even worse right there. What I'm trying to do is trying to make that look somewhat like, yeah, like that. Alright, so guys, those 3 angles that they gave you here are interior angles, and we know that they're interior angles really, honestly, truthfully, yeah, because that's what happens when they just give you a triangle and they just say angle S or angle T, then they're talking about one of the interior angles. Yeah, I mean, especially if they didn't ask you to draw out an exterior angle. But yeah, so here they've given you all 3 interior angles. Alright, and again, folks, we've done plenty of examples in our previous lesson, and even some of our examples today kind of reiterated what we talked about in that previous lesson on the triangle angle sum theorem, where all 3 of the interior angles of any triangle adds to 180 degrees. Okay, guys, that's it. I'm done. That's all. goodbye. I hope that this was helpful. Yeah, I gotta go. All right. Bye, folks. I really do hope that this has been helpful to you. That's it.